Barbara graphs a family of equations of the form y equals ax squared plus 1. How does each new graph compare to the previous graph as Barbara increases the value of a from 1/2 to 1 to 1.5 and finally to 2? So she's going to be making several graphs. They're all in the form y equals ax squared plus 1. So she's going to do y equals 1/2 x squared plus 1, y equals 1 x squared plus 1, and y equals 1 1/2 x squared plus 1, and then y equals 2x squared plus 1. All of these are quadratic equations because they have the x squared. So we know our graphs are going to be parabolas, and that's the U shape. We remember that the A is like the slope. It determines how steep our sides are and therefore how wide our parabola is. And this plus 1 is like our y-intercept on a slope on a linear equation, and so it slides my parabola up or down. I've got a little graphing tool here that we can just take a look at what happens. In this graph, b is 0, so we'll just leave b at 0. C is 1, and you can see when I move this up to 1, my parabola moved up 1 unit. Since this is a 2, halfway up would be 1. And you can see that changing C here just shifts it up or down depending on which direction I go. We talked about A making it wider or steeper or wider or narrow, or because it changes the steepness of the sides. And watch what happens as I change it from 1 to larger numbers. You see it getting narrower and narrower. When I get down here below 1, it starts getting very wide. And then when I turn negative, it flips upside down. Again, getting narrower and narrower as the absolute value of this gets larger. Now you're not going to have that tool when you're working on the TAKS, so let's use what we do have, and that's the graphing calculator. And we'll graph these. In the function editor, we'll put them in one at a time. 1/2 x squared plus 1. And there's our parabola, shifted up 1 unit as we expect. Now let's put the next one in. We'll leave that one on. 1x squared. Graph. Sure enough, there it is again. Notice that it still goes through at 1, but now it's a little more narrow. We'll do 1.5. And I can put this in as 3/2, or I can just use the parentheses. Plus, oops, 1 plus 1/2 x squared. And you see it gets a little bit more narrow. And then finally, 2x squared plus 1. And it's hard to tell, but it did get more narrow. We can zoom in. And there's our last one, just a little more narrow. So, looking at our choices here, each new graph is above the previous graph. Well, that's not true. Each new graph is wider than the previous graph. That's not true. Each new graph is narrower. That is true. Each new graph is to the right, and that's not true. So we have our answer. Let's zoom back to standard, number 6. And I want to show you a way that we can put all these in at the same time. So we'll clear all of these. We're going to put a set of values, so we're going to use the braces. We're going to do the 1/2, the 1, and instead of 1.5, I'm going to use 3/2. And my last one is 2. Close these braces. Those are all x squared, and then plus 1, and graph. There's the first one, second one, third one, and the last one. So that's a nice way to graph 4 different graphs and not have to do all that entering.